Alright, and welcome to Graphing Linear Functions Level 2. Now, in our very first example, we're going to graph the following function, 3x plus 6y equals 12. And you'll notice something. When we were talking about linear functions in our previous video, we were talking about them in the form of y equals mx plus b, where y was by itself. And what do I mean by itself? Well, I mean, like, here's the equal sign, and y is the only thing to the left of the equal sign. And so it turns out, in order for us to graph this function, 3x plus 6y equals 12, well, similarly, we need to get the y by itself. So the first question becomes, what should I get rid of first? Should it be the 3x or the 6 in front of the y? And so, in fact, we always want to move our x first. The opposite of a positive 3x would be a negative 3x. And, of course, what we do to the left side of the equal sign, we, of course, have to do to the right side. Now, I drop down, and we are right 6y equals, but notice something here. We have 12 minus 3x, and this is where a lot of students make a mistake. A lot of students will do 12 minus 3. Well, we can't combine these. They're not like terms. So, in fact, we simply write 12 minus 3x. Now, from here, we're essentially done in one step. How do you get rid of the 6? Well, you have to divide. And so we divide every single term individually by 6. Now, I've found that when you divide every term individually by 6, that makes this the easiest way to do this. So we can write this, y equals, and ask yourself, what is 12 divided by 6? Well, that would give us 2 minus, and 3 divided by 6 is actually 1/2. You can plug that into your calculator, or you could reduce it by dividing the top and bottom by 3. But we have this function, y equals 2 minus 1/2 x, which is very convenient because now we can see, hey, this negative 1/2 is in front of the x. It must be my slope, negative 1 over 2. We also see this constant of 2, and that's our y-intercept. So, ask yourself, which one of these is our starting point? Well, we know from the previous video, it's going to be where our y-intercept is 2. So we'll go 1, 2 units. And we know that our slope is negative 1 over 2. And think to yourself, where should I put that negative? Does it go at the top, or the bottom, or both? And I find it's always better to put it with the top. So this negative 1 tells us we're going to go down 1. And this positive 2 tells us we're going to go to the right 2. So down 1, right 2. Well, what if we do that again? What if we go down 1 and right 2 again? Well, we wind up right there. And of course now, we can graph that linear function. Let's pretend that I actually hit these points. Okay, so there's our linear function. And let's talk about our domain. Well, to recap what we said in the first video, this graph extends forever to the left, it extends forever to the right, and so our domain is negative infinity to positive infinity. Also, in terms of going down and in terms of going up, well, this line never stops going down and it never stops going up, so our range is also from negative infinity to positive infinity. Now, before we solve this x-intercept, I just want you to look at the graph, and can you tell me where we put this point right here, not where the line actually is, but where we put that point, could you just tell me what the x-intercept is? And you should be able to. The x-intercept is clearly at 4, okay? So as we know that it's crossing right there at that point at positive 4. However, what if you're not too familiar with the x-intercept? How do you solve for it? Well, we know that the x-intercept is going to be where y equals 0. So how do we tackle that? Well, we take our original function, 3x plus 6, but instead of y, we're going to put a parentheses, and we're going to plug in that 0 is equal to 12. Now we know 6 times 0, that's 0. It's gone. So essentially we're left over with 3x equals 12. And how do you get rid of the 3? Well, we divide both sides by 3, and we see that our x-intercept is at 4. So you could have seen that by looking at the graph, because that's pretty obvious, or by simply plugging in 0 everywhere we see a y and getting that our x-intercept was at 4. Alright, I would encourage you to pause this video, finish writing down any notes that you need, and let's move on to our second example. Okay, here we are in our second example, and it wants us to graph the following function: 5x minus 2y equals 4. Now remember, we always want to get these in the form of y equals mx plus b. And so when I look at this, if I want to get y by itself, I have to ask myself, should I move the 5x or the negative 2 in front of the y first? Well, we know that we always want to start by getting rid of our x first, and ask yourself, what is the opposite of positive 5x? Well, that would be negative 5x. And what we do to the left, of course, we have to do to the right. So we subtract 5x from there as well. So once those zero out, we have negative 2y is equal to, and looking at this 4 minus 5x, can those combine or should they stay separate? Well, since 4 doesn't have an x, we can keep them separate and we have 4 minus 5x. Now from there, how do you get the y by itself? Well, whenever we have a coefficient in front of a variable, in order to separate it away, we always divide. And I would like for you to divide each term individually, so minus 2 minus 2. And this will actually give us y equals, and now because we've divided it individually, we can reduce each part separately. So what is 4 divided by negative 2? Well, that would be negative 2. And what about negative 5 divided by negative 2? Well, for that we can just write plus 5 over 2x. And from there, you have to determine which of these two numbers is our slope and which one's our y-intercept. Well, if you will recall, where do we find the slope? It's always in front of the x. So our slope is 5 over 2, and our y-intercept is, of course, this constant, negative 2. Well, when we go to graph that, which one of those is our starting point? And we know our starting point is going to be that negative 2. So on the y-axis, we go down 2 because it's the y-intercept, and we put our very first point. Now when you look at that 5 over 2, where is that telling us to go? Well, we know in the change in y, or the top number, it's telling us to go up 5, so 1, 2, 3, 4, 5. And this bottom number is a positive 2, that's telling us to go to the right 2, and we can go there. Now this is going to be a little tricky to squeeze in, but remember, a linear function has a constant rate of change. And so from our first to our second point, we went up 5 and to the right 2. Then from our second to our third, we'll go up 1, 2, 3, 4, 5, and again to the right 2. And once we have those 3 points, we can draw our line through them, which it appears I did a better job this time rather than the last. Now remember, for linear functions, unless given any specific restrictions, the domain will always be from negative infinity to positive infinity, and the range 2 will be from negative infinity to positive infinity. Now the very last thing we want to look at is the x-intercept. And if you notice from my graph, if you were just to take a look, it might look like the x-intercept is at positive 1. So, let's put a question mark right there. Is it at positive 1? And let's solve for this mathematically. So we see that we have 5x minus 2y equals 4. So we're going to write 5x minus 2 and ask yourself, when finding the x-intercept, what is it that we set y equal to? Well, we want to set y equal to 0. Okay. Negative 2 times 0 is 0. It essentially goes away. We have 5x equals 4. And how do you get rid of 5? Well, we divide both sides by 5, and we get x equals 4 over 5. So if you were to look at that graph and say, well, hey, I thought it looked like the x-intercept was at 1, you wouldn't be too far off. 4/5 is very close to 1. However, this is why we always have to check our math by plugging in 0 for y, because just because it looks like something doesn't mean it's exactly at that point. Alright, I hope this helps. and I'll see you guys in our level 3 video.